we will solve GATE 2024 EC problems. So the first question is based on the uh, positive feedback circuit, that is oscillations. We have Barkhasen criteria for oscillation. For sustained oscillations at output, it has to satisfy two conditions. One is magnitude of loop gain should be 1 and the angle of loop gain should be 360 degrees or 0 degrees. Loop gain is nothing but, let us say I have a feedback after the op amp, something like this. Loop gain is nothing but, if I break the loop, if I apply a test voltage Vt, I will get some voltage V return here. The ratio of loop gain is V return by V test. Here in this question I am breaking the loop here and I am applying a test voltage Vt here. Here if I have Vt, because of negative feedback the voltage here will be Vt and the current flowing in this resistor is Vt by R, and the same current will flow in the resistor R1. So the node potential Vx is determined from this equation. The current flowing is Vx minus Vt by R1, which is Vt by R. So if I take Vt terms to one side, it will be Vx is equals to Vt into R plus R1 by R. So I have Vx potential here. From here I have a feedback network. This is the feedback network. I have to find out relation between this node and the output node. For that I will simplify this network first. This is the feedback network we have. Here we can clearly see that R and C are in series. So I am calling this equivalent resistance as Z1. Z1 is R plus 1 by SC because they are in series. So it will come out to be SCR plus 1 by SC. And this Z1 is in parallel with R. So I am calling this equivalent resistance as Z2. Z2 is R in parallel with Z1. So we got Z1 as SCR plus 1 by SC. So the equivalent resistance will be R into SCR plus 1 by SC by R plus SCR plus 1 by SC. If we simplify this, we will get this one, R into, you can simplify, this is R into SCR plus 1 by 2 SCR plus 1. After that I will replace this entire circuit with Z2 and find out the relation between Vx and this node voltage by simple voltage division. So here I am calling this node as Vy and I will apply voltage division here. So Vy is nothing but, Vy is Z2 by Z2 plus 1 by SC into Vx. Z2 we got as R into SCR plus 1 by 2 SCR plus 1. same Z2 here plus 1 by SC. If we simplify this, we will get this expression SCR into SCR plus 1 by S square C square R plus 3 SCR plus 1. So this node potential is, so here we have the circuit. R and C. So we got this node potential as Vy. Vy is this expression, and here this potential is V return. We have to find out V return. From here to here, it is a simple low pass filter transfer function. The relation between V return and Vy is 1 by 1 plus SCR. So to get V return, I have to multiply Vy with 1 by 1 plus SCR. If I do that, 1 plus SCR, 1 plus SCR cancels out, and the loop gain will be this function SCR by S square C square R square plus 3 SCR plus 1 into, earlier we got Vx as Vt times R plus R1 by R. I have replaced this here, this expression. So we have said that for Barkhausen criteria for sustained oscillations, the loop gain phase should be 360 degrees or 0 degrees. So we'll find out the phase relation of this. From this we will get relation between R1 and R and the frequency of oscillations. Here the numerator will give 90 degrees phase because the angle is tan inverse imaginary part omega RC. Real part here is 0, so it will be tan inverse infinity and just 90 degrees. So while coming to the denominator part, S square C square R, if we put S is equals to j omega, it will come out to be minus omega C square R square plus 1. The real part is 1 minus omega square C square R square plus the imaginary part is 3j omega R. For it to be 0 degrees, this has to give a phase of 90 degrees. For that, similar to the above case, real part should be 0. If real part is 0, it will be tan inverse 3 omega CR by 0. It will be infinity tan inverse omega, that is 90 degrees. For real part to be 0, omega square C square R square should be 1, which will give us the frequency of oscillation as omega RC. Omega is equals to 1 by RC. And for the magnitude condition, magnitude of loop gain should be 1. So if we put omega equals to 1 by RC, the magnitude of this part will be 1. This will be R into R plus 1, R plus R1, and here this part is 0, so only this term will remain, 3 will remain, and this R will remain. So R plus R1 will be 3R, R1 will be 2R. So the answer is option D, 2R and 1 by 2 pi RC frequency of oscillation. So the second question is based upon the op amp. So in this question, they have given that the input signal is a triangular wave which is varying from +2 to -2. with a time period of 8 microsecond, and we have to find the relation between Vi and VO1, Vi and VO2. How will the waveforms look like? So here we can see that the op amp 1 is in positive feedback. So if, let us say, this node potential is Vn, and let us say this node potential is Vp, if Vp is greater than Vn, output will be positive Vsat. If Vp is less than Vn, output will be negative Vsat. So initially the input voltage is greater than 0 volt, so the output will be at positive Vsat. So I'll draw the network here for reference. This is connected to ground. This is VO1. This 100k, this 10k, this is Vi. For positive half cycle or when output is plus Vsat, this node potential Vp will be result of superposition of these two sources. This is at positive Vsat and this is at Vi. If I consider only Vi, Vp will be 100 by 110 times of Vi, plus if I consider only VO1, this will be 10 by 110 times of output is plus 10 volts. So when this node potential goes below, when Vp is less than 0 volts, VO1 will go to minus Vsat. So for that we will find out the value of Vi. What is the value of Vi for which output will be minus Vsat? It's nothing but 10 by 11 Vi plus 10 by 11 is equals to 0 or less than 0. If I take 10 by 11 common, will be 1 minus 1 plus Vi. For this, Vi should be less than or equals to minus 1 volt. So we can see in the graph, when Vi crosses minus 1 volt, the output will go from positive Vsat to negative Vsat. So So till this point, let us say this is positive V sat plus 10 volts. Okay, this will be 5 microseconds. 5 microseconds. So we have to look for the other condition also. When output is minus V sat, Vp will be 10 by 11 times of Vi minus 10 by 11 volts. So if this crosses 0 volts, when Vp is greater than 0 volts, greater than or equal to 0 volts, VO1 will be positive V sat. Take 10 by 11 common, Vi minus 1 should be greater than 0 volts. For this, Vi should be greater than or equals to 1 volt. When Vi is greater than 1 volt, VO1 will go to positive V sat. So this will occur in the second cycle. This will occur at 9 microseconds. Let us say I'll do one thing. T is equals to 9 microsecond. This will go to plus 10 volts. This will happen for every 4 microseconds. Yes, 4 micro. Then again at 13 micro, it will come to negative V sat. So when this is compared with input, there is 1 microsecond delay with respect to input. Okay, so now we have to find out VO2. This node potential is VO1 and this is ground because of negative feedback, and the current IL is nothing but 1 by L integral VO1 dt, and VO2 is minus 1k times of IL. This 1k by 1 milli times of integral VO1 dt. In one thing, I'll write it separately. we can see that VO2 is 1k by 1 milli into integral VO1 dt, that is nothing but 1 micro into 10t. T is equals to 1 microsecond, the output will reach 10 volts. At 1 microsecond, the output VO2 will reach 10 volts. After that, it will stay at 10 volts till 5 microseconds. At t is equals to 5 microseconds, VO1 changes from plus 10 to minus 10 volts instantaneously. So the frequency content here is infinity. For this sudden change, the inductor will behave as open circuit. Inductor will behave as open circuit. This will be open circuited. So the output will become 0 volts because of virtual short. So in negative half cycle, similarly VO2 will be minus 1 micro times of 10t. After 1 microsecond of time, VO2 will reach minus 10 volts from 0 volts. So at 5 microseconds it will be 0 volts, and from 5 to 6 volts, 6 microseconds it will reach negative 10 volts, and then it will stay at 10 volts till 9 microseconds, and then again it will go to 10 volts at 10 microseconds. So this will continue. So the output VO2 will be a trapezoidal waveform. So the answer is VO1 is delayed by 1 microsecond relative to Vi, and VO2 is a trapezoidal waveform. Thank you.